Okay, so today we are going to create a VM machine on AWS using its EC2 service. Yesterday we had talked about a few important services Azure provides, which are useful for the DevOps, entire DevOps activity. So out of those services which we had discussed about, we are going to talk about an EC2 service today. So I'm already logged in my AWS console using the credentials, and now here in this search I'm typing EC2. So this is the EC2 service. So let's click on this. After clicking on this EC2, so we land on this particular page. Okay, this is a kind of a dashboard of our EC2. So here it shows how many instances are running. So currently we do not have any instances running, right? So also it shows us the key pairs. We will talk about this in a short while. Now even about the security groups also we will talk about, but let's go step by step. I am just scrolling down, and here there is an option to launch instance. So let's click on this launch instance. Okay, so here we have to provide a name to our instance. I'll say Docker instance, some name. Let's scroll down. So here it asks us to select which type of operating system we want on a particular EC2 instance which we are creating now. So I'll select Ubuntu. Okay, now here there is a concept called AMI. AMI is what? Let's understand. This is like a Docker image. Like for creating our container, what we do is we create a Docker image, right? And using that Docker image we start the containers, right? So here Amazon has created the images of different machines, which are called as, those are not obviously a Docker images, which are the equivalent to, you can say, a Docker image, which has got all the required files for a particular machine and all the required packages and all. So those are called as AMI, Amazon Machine Image. And now using this Amazon Machine Image we can create a machine what we want, right? So here we have the different options available. Like you can see Ubuntu server 22.04. so this is the version of the Ubuntu operating system, right? So also it shows us that this is eligible for a free tier. So currently we are using a free tier, right? So but if you go down and if you check few other alternatives, so those are all paid alternatives here. So we are going to go ahead with this free tier eligible alternative. Then let's scroll down and let's check this out. What is the architecture we want? So let's go ahead with this 64-bit. This is the instance type again. So there are different instance types, okay, available. So I'll just click on this compare instance types, so we can check out here what are the different instance types available. So we have t1.micro, t2.micro, t2.nano, t2.small. These are all the types of instances. Basically there are different types of instances depending upon their memory, right? So if you check this t2.xlarge, so this has got a 32 GB RAM. If you check this T2 micro, which we have selected here, so it has got a 1 GB of RAM, right? So we can go ahead with this T2 micro because we are anyways going to simply install Docker there and we are going to run few containers there. But which type of a instance you would like to create depends upon what are your memory requirements, right? In terms of RAM, what are your memory requirements, and accordingly you will create a type of an instance here. So if you are going to use the usage of that particular EC2 is going to be a quite extensive. So like in terms of, let's say you are going to deploy a application there which has got a lot of memory consumption requirements, then definitely T2 micro will not be a correct option for you. Here also in these vCPUs you can see how many CPUs are there. So for T2 micro there is 1 CPU, for T2 XLRs there are 8 CPUs. So this again will provide you a good performance. T3 nano, T3 large, so there are a lot of options we have available, and depending upon the option you select you would be built basically. So the kind of an advanced machine you will get or you will take, let's say this T3 extra large, so accordingly you would be built, right, for your usage. So let's go ahead with this T2 micro. Let's select the instance type and let's scroll down. Now here there is a key pair option. Key pair. Now if you remember, like when we were working on Git, right, so we had talked about SSH key pairs, private key and public key, right? So that SSH key pair, which we use to log into our Git repository, right? Similarly, to connect to this EC2 instance, so there are different ways we can connect to this EC2 instance, right? So I can connect, once the EC2 instance is created, I can go to my CMD and using SSH I can connect to that EC2 instance, right? So for that purpose we need a key pair, public private key pair, so that that connection can be established, right? So this is what the key pair is. So let's create a new key pair. Okay, let's go ahead with the given options. So we will give one name called Docker instance. This is the name of a key pair, and I'll just click on this create key pair. So what it will do, it will create a pair of keys, private, public. Okay, so let's click. So I have got my key here, Docker instance. Okay, we will use it afterwards once the instance is created. Let's scroll down. So here there are the network settings. So this is a VPC. We will talk about a VPC, but not now. A subnet, and what is important for us is this particular section, security group. This particular section is important for us. Now why it is important, let's understand. I'm just opening a Word and I'll explain you why this security group is important for us. So basically we have an EC2 instance here. This is our EC2 instance. Okay, now this EC2 instance we are going to, let's say I'll start a application inside this, say a server. So that server is running on port 8080, for example. Okay, so port 8080, I have one server running here on this EC2 instance. This is my EC2 machine. Now this EC2, say I want to access to this machine on port 8080 from somewhere outside. Now what I can do is, Like if you are aware of the firewall concept, let's say on this particular machine of mine, I have few services running, like Jenkins is running on 8080, Nexus is running on 8081, IIS is running on 8085, and from some other machine I want to access these services who are running on these ports. So the firewall of this system should allow the incoming traffic, right? So this is our machine, and this is the machine from where I am accessing the services running on this EC2 or any machine for that matter. So this machine's firewall should allow the incoming traffic. So incoming traffic, this is the incoming traffic. Okay, this is the incoming traffic. So this incoming traffic should be allowed by the firewall of this EC2 instance. Okay, so this firewall set up here on this system, if it doesn't allow the incoming traffic on particular ports, then you won't be able to access services running on here. Now this is true not only in case of EC2, this is true even in case of on-premise machines. So if you have one on-premise machine, two on-premise machines, let's say one on-premise machine, you have few services running on different ports and you want to access them from other machines. So the firewall of the machine running those services should allow the incoming traffic on those particular ports. Okay, so for our EC2 instance,
with respect to any applications, like can you quote an example to better understand it? So let's say,
so for example, Jenkins, you can say.
Okay, so like EC2 is a service which will offer me one virtual machine, right?
Correct. And on that machine, let's say you have installed Jenkins. Let's take an example. And you are running that Jenkins there on that EC2 instance. Okay. Your Jenkins is running on 8081.
Okay.
Now you want to access that. Now this EC2 instance will get one IP address. So let's say that IP address is 10.9.5.6, something like that. And now on your browser, you will open your browser, you will give this IP address :8081. This is how you will access the Jenkins running in the EC2 instance, right?
Okay.
Now this EC2 instance should allow the incoming traffic on this 8081 port. Are you getting my point? Otherwise you won't be able to access.
Okay, so if I access it from some other IP address, let's say 11.9.5.6,
Whatever.
then I get totally different machine. If I take a totally different machine and then try to access it, then that particular request should be accepted or should be forwarded, is what you meant to say, right?
Yes. So I have this machine where my Jenkins is running. I have this machine where I want to access that Jenkins. Now there should be like this particular EC2 machine should allow the traffic to be coming in on this port 8081.
Okay.
Right, is what I am saying. So let's say if you have any other service also running, let's say Nexus on this system 8082 Nexus. So this Nexus also you are going to access it from some other machine. Say your own machine, your own laptop, you are accessing this services running on this EC2. So EC2 should also allow the traffic to be coming on 8082. Right? So every machine has got its own firewall rules. Even my system, forget about this EC2, that's why I am saying it's not specific to EC2. If you go on your system, okay, now here if you check, there is a firewall. Now here in this firewall, do you see this inbound rule and outbound rule?
Yeah.
So what is the meaning of this inbound rule? That if I have any service server running here on my system, and say we both are working in the same organization, we are in the same network, okay, and I have some server running on my system, say Jenkins again, which you want to access from your system. Okay, now my Jenkins is running on 8081. Fine. Now you would be sending a request for my Jenkins running here on 8081. So you would be opening your browser and you would be saying HTTP colon, say my machine's IP address, let's say that is 10.8.9.7 something like that, colon 8081 is the URL which you will put in your browser. Fine so far. Now once you will put this URL in your browser, what it will do, it will send the request to my machine on this 8081 process. Okay, so that request will come to my machine first for 8081. Now what is this port? Let's understand so that it would be better to understand this. So when you access any, say this machine is my IP address, and you mention that you want to access a service running on 8081 port. So what happens is your request first comes to my machine, my machine's network adapter, and then my machine knows which process, like whatever the process are running on my system, out of those processes, which is the process accessing the incoming request for 8081. Say I have got these many processes running here in my system. If you check out these processes, so there are a lot of processes here. Out of this, one process, a Jenkins one, is going to accept the request on 8081. Okay, the requests targeted for 8081 is what it is going to accept. Now what happens is when you send a request, so that request first will come to my machine's network adapter. My network adapter knows out of the running processes on my system, which is the one which is going to accept the traffic on 8081. So out of the processes running, say I have got 100 processes running, to which process the incoming request should be forwarded to understand that the port is used. So port is basically to understand for our network adapter to which process the network traffic should be forwarded to. That is what port is. Okay, so when you send any request, that request first comes to the machine's network adapter. So that network adapter has this IP address actually. So this is its destination, network adapter. Once the request reaches to the network adapter, which process it should be forwarded to. So for that purpose, network adapter uses the port. So network adapter checks, okay, in the incoming request, what is the target port they have mentioned? So they have mentioned 8081. Okay, which of the running processes are accepting the traffic on 8081? Let's check. So it checks it, and the process which has started itself to access or accept the request on this 8081 process, it forwards that request to that particular process. That is the significance of port, first of all. Now coming to the second point of this. Now when you will access the request, or when you will give the request from your browser like this, my network adapter of my system should accept it. That is the first step. Once it will accept it, then only it will forward it, isn't it? Now my firewall rule should allow that first, that anyone should be able to access the 8081 port. Okay, so that is what you define in your inbound rules. Inbound rules are always the incoming traffic rules, which port you want to allow the incoming traffic to. Outbound port is which ports you want from your machine, from your system, which ports your machine should be able to send the request to. Inbound rule is which port your machine should be able to access the request for. So if someone is accessing the request, someone is accessing a service running on 8081, do you want to allow that or not? So that is what you define in inbound rule. And outbound rule is for outgoing traffic, inbound rule is for incoming traffic. Similarly, for EC2,
So at the same time, we can access or send multiple requests as well, right?
yeah, that's absolutely fine. Once the port is available for the connection, no, you would be able to send multiple requests. That's not a problem. The main thing is every machine has got the firewall rules defined. Okay, to basically not expose that machine for anyone to connect to it, right? So every machine has got one check there, which ports request should be allowed to come in, which port request should be allowed to go out. So these inbound rules, once the traffic is allowed, you can send a number of requests. That's not at all a problem. But the firewall rule is for this particular check, which traffic should be allowed in to come in, which traffic should be allowed to go out. Now the way we have the firewall rules here, EC2 instance also we can define such kind of firewall rules, right? So I have got my EC2 instance here. Now this EC2 instance, anyone would be able to access it from anywhere. Okay, but if I want to have the firewall rule saying that my EC2 instance access should only be allowed on port 8081 and 8082, no other services or no other port should be opened. So if I want to set the firewall rules for my EC2 instance, then that is what the security group is for. This security group, do you see this firewall security groups? So security groups are nothing but firewall rules. I'll show you how to create a firewall rule, don't worry. But for now, let's go ahead with this create security group. Allow SSH traffic. This is very important. Once the EC2 instance is created, we are going to access that EC2 instance using SSH key. That's what I had mentioned initially, right? We had created one key pair where we have got public key and private key. Now using this public and private key pair, we are going to access this EC2 instance from my command prompt. From here I am going to access my EC2 instance. So when you access the EC2 instance, you use SSH. This we have already talked about when we were working with Git. Now this SSH, when you connect to any machine on SSH, so you need to have a SSH client, and that EC2 instance would be having SSH server. So this SSH client and SSH server, using these you are going to connect to that machine. That is point number 1. Now any SSH server by default runs on port 22. What is the number of port? 22. So once we will create an EC2 instance, so this EC2 instance here, it will have SSH server running on port 22. Now if you want to connect to this EC2 instance, let's say this is my machine, and from my machine I want to connect to this EC2 instance using SSH. So which port my machine need to have SSH client, and this EC2 instance need to have SSH server running on port 22. Now this machine, if it wants to connect to EC2 on port 22, then this 22 port should also be allowed in the firewall, in the security group of my EC2 instance. The way here we create the inbound rules for different ports, 8081, 8082, 8083, whatever the services you want to allow the traffic to. So for those you will create here the inbound rules, right? Similarly for EC2, you should have the inbound traffic allowed on port 22, otherwise you won't be able to connect to that machine. So if you check this out, in this it asks you this option, allow SSH traffic from. So if you check this checkbox, it means you want to allow the traffic to be coming in on port 22. And here if you see this drop down, so this, if you check this out, anywhere, meaning what? Anywhere means anyone can access the machine. So if I am creating an EC2 instance, you can also access that EC2 instance using its IP address. Okay, that is what anywhere is. But if you want to only limit the access to this EC2 instance from your own laptop or from your own machine, then you should select this option, My IP. My IP is what? The source of the request should be coming from this. If it is coming from this IP address, then only allow it. If you select anywhere, meaning what? Any machine wanting to access the EC2, allow that access. Okay, so this anywhere is not a secured option to go for. You should always select this. So even if your EC2 instance IP address, anyone gets it, even if anyone gets the IP address of your EC2 instance, he or she will not be able to connect to it if you have this option selected. But if you have this anywhere selected, no, anyone having the IP address of your EC2 would be able to connect to it. Okay, please understand this. So let's go ahead with this My IP. So I want to access my EC2 only from my laptop, this machine where I am currently working on. So this allow HTTP traffic from the internet, allow HTTPS traffic, let's forget about it right now. Let's go ahead. So we don't want any external configuration, the storage configurations. Let's scroll down. Number of instances, I want one instance to be created of Ubuntu. Okay, T2 micro is our machine configuration, and let's click on this launch instance. So it is creating an instance now. See, it is creating an instance, and this is the instance it has created. See, this is the instance, and it is still pending, like it is being created. It has not yet created completely. Once it will be in the running state, then we would be able to connect to it. I'll show you how to connect to the EC2 instance, don't worry. But this is the EC2 instance. Let's go inside. By the time it is getting created, let's go inside and check few details here. Now if you see, this is the public IP, and this is the IP we need to access this EC2 instance. Okay, this is a private IP. Private IP means the IP which can be accessed within the VPC. Now let's talk about that. Okay, now you have got a network created, which is called so this is a network, say a VPC network, virtual private cloud, VPC stands for. Now this is one network. Inside that network you have created your EC2 instance. This is your EC2 instance. Okay, now this EC2, this is one EC2 instance, and this is a VPC. So the way you have one EC2 instance created, you can create multiple EC2 instances in this VPC. 1, 2, 3, multiple. Now let's understand the difference between private IP and public IP. Now let's say this is one machine, yet another EC2 instance, EC2 underscore 1, and this is EC2 underscore 2C. Now you want to access this EC2 machine from the EC2 1. Now remember, both of these are in the same virtual private cloud, VPC, same VPC they are in, right? So if you want to connect this machine from here, which both are in the same VPC, so you would be using private IP, which is only available for the machines which are in the same VPC as that of the one you want to access. Okay, so if you want to access this from this machine, you want to access this, again they are in the same VPC, same network, so you would be using private IP. But if you want to access this VPC from somewhere else, the machine which is out of this VPC altogether, then you cannot use private IP, you need to use then public IP, right? So if you check this out, our VPC has got a private IP, our EC2 I mean has got a private IP which can be used to access this EC2 to access it from within the same VPC, and this public IP is for accessing our EC2 from outside that VPC. So if I want to access my EC2 from my laptop, this particular machine, I cannot use private IP because my laptop is not in the same network my EC2 is, right? But if I create one more EC2 instance in the same VPC, and if I want to access the one which I have created first, then I can use this private IP, right? So this is what the difference between public and private IP. Now here we can see the instance state which is in running now. Now this is a public IPv4 DNS, that's fine, we will talk about it little later. But right now what is important for us is checking the instance type. This is our instance type. This is the VPC which is connected to my EC2 instance. Let's scroll down a bit, and the important point is this. So this details is fine, but the important is this security. Now this is the important point, security. Now this is the security group which is connected to our EC2 instance. Now we should open this security group, and what we need to check is, see here, this is important thing, inbound rule. Do you see this inbound rule and outbound rule? So inbound rule is for incoming traffic. So if you want to access your EC2 instance using SSH, so you should have that allowed, that inbound rule. I'll show you, edit inbound rule. See here, SSH. So currently our SSH traffic is allowed to come in, port is 22, and from where you want to allow this traffic, right? So I want to allow it from my specific machine, from my laptop only. This is what we had selected at the time of creation of the machine itself. At the time of creating this EC2 itself, if you remember, there was a security group section, and there I had checked one checkbox, allow SSH traffic, and in the drop down I had selected my IP. So because of that setting, this inbound rule has been created at the time of creation of the EC2 itself. After that also you can create. It's not mandatory that you have to create these all inbound rules when you will create the EC2. You can set, let's say at the time of creation I was aware that I want to access this EC2 on port 22, so I just selected it. But after that, if I start any server, let's say Jenkins server on 8081, now if I want to allow the incoming traffic to that particular port, then I can create the incoming or inbound rule for that 8081 after the creation of EC2. So it's not mandatory to set all the inbound rules at the time of creation of the EC2. After creation also you can set. Okay, so this is what that security group and inbound rules is. Now interesting point is, let's go to this and let's connect to this EC2. So this is in running state now. Now we can connect. So just select this and you can say connect. Now you can see the different options here. See, EC2 instance connect. So this you can use, EC2 instance connect. Then there is another option, that SSH client. This is what I was talking about, this SSH client, this one, this. I'll show you how this works, because this is a pretty much simple. If I click on this connect now, it will connect to my machine. This is not that much, I mean, this is the preferred way, but if you do not have an access to this particular console, then you won't be able to connect to this machine in this way. In that case, you have to connect to your machine in this way, this SSH. So I'll show you this now. Let's understand this command. Let me copy this and let's understand this. This is the interesting way. So our SSH client -i stands for, like -i, when you will say, you have to provide the path of your private key. Now if you remember, Rameshri, when we were creating an EC2 instance, there was an option to create a key pair. So I had selected that key pair option and I had got my, see here, private key. See, this is the private key. This is similar to what we had seen in case of Git. See here, this is the private key. In case of Git also, we were generating a key pair, right? After generating the key pair, we were adding a public key on a Git, and private key we were keeping on our system, and we were connecting, we were actually connecting to our Git repository using that public private key pair. Same thing is happening here. So I have got this private key. So I can keep this private key anywhere for that matter. But let's say I have kept it on my C users, or I'll say I'll just copy it and I'll keep it somewhere else. Let's not keep it in downloads. I'll just go and I'll just say DevOps. I'll just go to our DevOps batch and I'll keep it here. Okay, so this is the path of your private key, and this is the username you want to connect to that EC2 instance, and this is its public IP, public IP DNS name. So what I can do is I'll just Control C. I'll just open the CMD from this and I'll paste this. So I'm saying SSH. As I'm already inside the directory where I have kept my PEM file, a private key, so I'm not providing the entire path of my PEM. I'm just mentioning the name. As I'm in that directory itself, so it will take it, with the help of name also. And this is my IP address, the public DNS. This is my public DNS of the machine I want to connect to, and this is the user I want to connect using. So let's hit enter. So here,
my file is looking something different actually.
sorry, I didn't get you. Meaning?
So my file is looking something different. Like when I downloaded this Docker instance.pem, so it has given me begin RSA private key and there is a key and ended with RSA private key.
Correct. So same is the case with my file also.
Oh, sorry. Okay, I was confused with the other doc. Okay, yeah, thanks.
Yeah. So same is the case with my file. Now there is one very important point. Do you see this error? This is very important error. So what it says is that this particular private key which we are accessing, okay, so it says that permission for this are to open, meaning this particular file, this file which we are using as a private key is to open, meaning if you go to its properties and go to security and advanced, so you can see it has got the full control. Anyone has the full control on this particular file. He can do anything whatever he want, right? So that is why it is ignoring that file, because it is too open, right? So what I can do is I'll say disable inheritance. Disable inheritance. I will just remove few full control. So I'll just remove this. I'll remove this. I'll remove this. I'll say okay. 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 So it is still having an issue in accessing this. Okay, just a minute. Permission denied. Oh, okay. So this is my, okay, let me add. Okay, let me click on OK and let me okay. So it is saying it's too open again. That's fine. So let me go here. Security. So go to advanced and I have to remove few permissions from here. So I will say just a second, let me just check this. I'll say disable. I'll say okay. I'll say okay. No, still it is saying that permission is denied. Okay. That's fine. Okay, just a second. Let me check the permission of our this file. C users, another D and a .ssh. We have a .ssh here. And where do we have our private key for our Git? Yeah, I'm just checking the private key for our Git actually. We had a private key created for our Git. I just wanted to check the permission of those of that file. So same permissions if I give, then it will use this file then in that case. Okay, let me check the permissions again. This is the problem with the permission of this file, nothing else. And let me just add authenticated users, and I'll say full control, apply, okay, okay. No, it is saying unprotected. Okay, now let me change a few permissions here. Let me go and just remove this. Unprotected. Okay, let me reduce the permissions. I'll go and change few permissions here. I'll just give read. I'll not give modify permissions. I'll just give read, and that's it. Still it is saying unprotected private key. Okay, no more authentication methods to try, that's fine. C DevOps patch, C:DevOps patch. Yeah, this is the file I'm changing the permissions for, right? So let me go and change the permissions again. This is the problem with this permission. Let me remove and add. Okay, let me just cancel this and let me do, yeah, let me just enable inheritance. Okay, just a second, I'll just remove this, apply. Okay, let me now authenticated I want to remove. So I'll say disable inheritance. I'll add I'll say okay, I'll say apply, okay. Right, I'll say okay. Unprotected private key, just a second, let me check this. Okay, so we have to change it to $700. Okay, Okay, we can do this. So what I'll do is I'll just open git bash and I will change the permission of this file to using chmod. Chmod is for changing the permissions, and the name of my file is okay, just a minute. Let me properties, because it is not allowing me to do anything now. So let me remove, apply, okay, and let me change the permission. Yes, I have changed it now, and now let me check it. So the permission, key file permission to 600, so I have changed it to 600. Okay, no, still it is saying that permission denied. Still it is saying unprotected private key. Fine. Set the 600 permission for private key. Yes, I do set it. Just a second, guys. Just a second. Basically, this is the same problem I had faced while working with Jenkins. So I had documented this in my book also. So I'm just checking this, like I had seen this and I had configured this, but now I'm not able to remember exact permission. So let me just check in my book. So I have mentioned this, like if we get this error now, this one, what should we do? So I'm just checking this. I think it is in Jenkins distributed 339. I have mentioned these steps, but I just want to check the exact permissions we need. And this, yes, correct, yeah. So I have mentioned this in my chapter, and here security tab, then we have to disable the inheritance. That's fine. Okay, admin and system is what we have to keep. Okay, so admin and system. Okay, I'll just say cancel advanced. I'll say disable, I'll say apply, okay, and then I'll say edit, and here we have to add system okay, system, and system we have to give full control, and admin. Admin we have to give full control. Okay, and now we have to restart the SSH. Open SSH. Yeah, this. So open SSH is disabled. Okay. It says that chmod 400. Okay, let me do this chmod 400. Correct. Okay, I'll just go and do properties, and I'll add authenticated. Yeah, I have changed the permissions now to 400, and now let's try running this command. Okay, it is still saying that unprotected private key. But I have got now this. Okay, never mind, we will see this, but right now we can connect to this machine using this option also, but definitely we will see that how to connect it from SSH client on our system, because that is the preferable way. This is just a simple way. Once you will click on that open client, no, it will on another tab of your system, it will connect. Okay, network settings, just a minute. Click on connect again. Maybe my IP address is changed. Okay, understood. Basically the IP address of our system. What is my IP? If you see, this is my public IP, my laptop's public IP. And now let's check the security group. Yeah, here in the security group, my IP. So this 123, 150, 158. 123, 150, 150. Now it is correct. Save. Or I'll just say anywhere. Just, I know that this is not the right way, but still I just want to check if it is getting connected. Yeah, I'm able to connect to my machine now. Okay, now let me change that security group back to my IP. So here, this is my security group, this one, and I will just scroll down and change my inbound rule. I'll just remove this and I'll say my IP. See. Okay, now let's check. It is not allowing to connect with that security group change. Okay.
Now, Pranavik, shall we stop the recording for now and